Today, we will discuss on the implementation of the k-means algorithm.
As for introduction, it computes the centroids and iterates until it finds optimal centroids, and then allocates every data point to the nearest cluster while keeping the centroids small.
The first step is to randomly pick a data point as a cluster centroid. Then in the second step we do cluster assignment. Let's say we pick the yellow point as the initial centroid. Now, we will calculate the distance of each data point with this centroid. The next centroid will be the one whose squared distance, dx2, is the farthest from the current centroid. In this case, the red point will be selected as the next centroid. Now, to select the last centroid, we will take the distance of each point from its closest centroid and the point having the largest squared distance will be selected as the next centroid. Here is an example of real-life implementation.
A network security officer collects real-time network data from his company-owned network system. He would like to find out how many categories of data traffic are there in the collected network data. For example, benign traffic, DDoS attack, and brute force attack. Hence, he uses k-means clustering algorithm to cluster the real-time network data into k numbers of groups. After that, he find out that there are 5 types of traffic in the network data. Then, he started to analyze what are the 5 types of traffics and assign them to different labels.
In order to use k-means clustering algorithm to determine how many types of network traffics in the real-time network data, the real-time network data needed to undergo data preparation steps first. The network security officer first read the data file. As shown in the results, there are 41 features in the real-time network data. And the data file consists of 148,515 rows of data. As shown in the result, all of the features are numerical data type, except for feature protocol type, service, and flag. Since k-means clustering algorithm cannot process non-numerical data, the network security officer need to transform feature protocol type, service, and flag into numerical data type. So, the network security officer transformed the variable UDP, TCP, and ICMP and feature protocol type into 1, 2, and 3 respectively. Same goes to other variables in feature, service, and flag. As shown in the result, after data transformation, the data type of feature protocol type, service, and flags change from object data type to numerical data type, which is int64. As shown in the screen, the data file is not scaled. Hence, the network security officer need to normalize the data into the range of 0 and 1. This is an important step that standardize the weights or importance of each variable, so that no single variable steers model performance in one direction just because they are bigger. As shown in the results, every features have been successfully scaled within the range of 0 and 1. After data preparation, the network officer started to cluster the data by using k-means clustering. First, he defines the range of cluster, k, which is from 1 to 50. He then calculates the sum of squared error, SSE, of each k. The SSE is used to measure the most suitable k for the data. After some times, the algorithm finished running. As shown in the result, k with value of 5 is the most suitable k value for the network data because it has the lowest SSE value among others. Elbow method graph is also plotted by the network security officer, and he get the elbow point as 5, which indicates that the most suitable k value is 5. Hence, he knew that there are 5 categories of data traffic in the collected network data. Then, he builds a final k-means clustering model to cluster his data into 5 clusters. He also plots a graph to visualize how his data is being clustered. In the original network data, there is no label for each rows of data. Hence, the network security officer adds the labels he gets from the k-means clustering model into the network data, so that he can visualize which data is in which cluster. At this point, the jobs of k-means clustering is done. The network security officer can start to analyze the data pattern of each cluster, and figure out the categories of network traffic of each cluster.